In this section of the chapter, 7.4, some useful array algorithms and operations, this is what I like to call Arrayapalooza, where it's just a bunch of stuff that the publishers had to cram together in here to say, hey, look how useful arrays are. And then to also give you one final additional extra caution about the idea of simply comparing arrays with the comparison operator. So first and foremost, and this is on page 426, comparing arrays. You cannot simply, like we see here in this statement, you cannot simply have first array equals equals second array and expect that equals equals to work the same way we could if we were comparing integers or doubles, etc. The way we would have to do this, and this is still on 426, the way we would have to do this is to compare array length first and foremost. So if the length of one array does not equal the length of another array, they cannot be equal. So that's the first easiest thing to check for. If the arrays are of equal length, that means that we have to go through and test each element of one array against the elements of another array. So this whole code sample piece here, which is on 426, this whole code sample allows you to compare one array to another. And this works, which is really nice, right? This is all of 13 lines of code from all the way up here, all the way down to here. In really relatively short amounts of code, you can compare arrays of any size. It's just that you want, because we've told you that there's a bunch of these magic wand solutions out there when using arrays, this one does not have a magic wand solution to it. Next, here, this is 427, summing the values of an array. What essentially the new wrinkle here is you would have an accumulator. So an accumulator is just something you store more and more and more and more stuff into, right? So you have your accumulator total plus equals units. So units is the name of my 25 element array here, at index, because we've got our simple loop here. And what that's going to do is accumulate the total value of everything we have stored in our units array. Neat, right? Getting the average value of, or the average of values rather, of a numeric array. You can take a look here. This is nothing different than we've been doing for getting average to date. It's just that instead of having, 12 different individual double variables to hold things like rainfall count, now you can do that in a much more compact data element, which is the array. Finding the highest and lowest values in an array. What this code sample right here is telling you, if we are looking for the highest value of an array, what we do is we start at 0. So that's at our index equals 1. So we start at the smallest element of our array, and we say that's our highest. Then the next time through, we compare it, the next element of the array, to highest, and if it's larger, we get a new highest value. And we keep going through and through and through and through each element of our array, and we compare each element to whatever we discovered was highest, which is really just the array at sub 0. If you want to do the lowest, you just do the opposite thereof. Instead of at index is less than lowest or greater than highest, it's less than lowest this time around. Not all that big a deal. And really that's it here for, I believe this is 7.4. All they're trying to do is bring your attention to, hey, look, we can use arrays to do some really basic mathematical things. We can look for the average. We can look for the highest. We can look for the lowest. And that is going to really get you through a lot of the data science stuff that we lean on arrays to do for us.